A very good evening to one and all. I am Lohita from EC Department of Brilliant Institute of Engineering and Technology. I welcome you all for the second day of ATAL FDP program on emerging trends in VLSI design for signal processing and communication system. I am honored to introduce today's resource person, Mr. Vamshi Krishna Ji Sir, Senior Technical Officer, CSIR, National Geophysical Research Institute, NGRA, Hyderabad. Mr. Vamshi Krishna Sir is currently serving as a Senior Technical Officer at CSIR, National Geophysical Research Institute, NGRA, Hyderabad. He holds a BTech in Electronics and Instrumentation from JNT University, Hyderabad, and an MTech in VLSI and Embedded Systems from Cochin University, Kerala. With over 14 years of R&D experience, he has contributed extensively to research and development in advanced domains of electronics, instrumentation, and emerging technologies. His research interests span across several industries. Those are drone UAV technologies, holding DGCA certificate pilot license for UAVs with payloads up to 150 kg, and embedded systems and cyber physical systems, and also emerging VLSA trends, ASIC design and sensors, MEMS, NEMS sensor development, magnetic and electromagnetic methodologies, and automation technologies in control and instrumentation. Mr. Vamshi Krishna sir is passionate about developing next generation technologies for real world applications, combining interdisciplinary approaches across electronics, geophysics, and automation. His expertise bridges both theoretical and applied aspects, enabling impactful innovations in scientific instrumentation and engineering solutions. Vamshi Krishna sir, it's over to you. You can continue with your meeting, sir. It's honor to introduce about you.
I am audible?
Yes, sir. Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Very good evening to everyone. Thank you very much for the wonderful introduction of me by Lohita madam. So before I'm going to the presentation, I would like to express my congratulations to the management of the Brilliant Institute of Engineering and Technology. Also, I especially thank the principal of the college, and also Dr. Naraya, professor, for giving this opportunity. I once again welcome for this evening talk on the AI-based technological advancements of solar microgrid system. So before going to the actual topic, I just want to give the brief introduction about myself and what kind of R&D is going on at our institute and at a CSR level. So I will quickly run few slides on the research areas what we do at our institute. So if you see the first slide, the CSIR, it's you can say pan-India network having roughly around 37 labs, which is working on different areas like aerospace and biology, biotechnology, and agro foods, mining, and like that. There are many other areas are there. You can see on the screen. And we particularly, I work in the lab CSIR National Geophysical Research Institute, where we work on the earth science and ocean, mostly on the earth sciences related R&D. So as a CSIR lab, we work on the some of the areas related to earth sciences. This is our institute. We work real on the four major themes, particularly like oil, gas, coal, and mineral exploration. And when it comes to the strategic sector, nuclear power plants and atomic minerals, and societal application when it comes to groundwater exploration, earthquake hazard assessment, and these are the societal applications. And what are the basic R&D? If you see the geodynamics of Indian plate and earth system modeling, these are the basic R&D areas which we concentrate from the NGRI. So, if you see what are the R&D achievements till now from the glorious past 1961 to till 2024 and 2025, promising future. So, the major activities like airborne survey with indigenous instruments, and there are some papers in nature from geography, and triggered hypothesis in 1967, seismic crustal image, and gravity map of India. So, entire gravity map was provided by NGRI, and lithospheric tomography, which was done at 1989, and satellite estimate of groundwater decline. Like that, numerical mantle simulation. There are also gas hydrate identification and drone-based magnetic recording in 2019, which was closely working on the drone-based magnetic survey in 2009. I was lead researcher in that area. And geochemical baseline map of India. And there are a few papers in science in 2021. Like this, we have published more than 100 books and encyclopedia, 5,500 papers in roughly, which these are the R&D achievements in NGRI. Also, we see the promising future for the geological hazard assessment and water security and energy security, minerals. Right now, the AI and ML era for the geosciences. And some of the unique geophysical research institute for the near surface to the deep earth exploration studies are you can see there is a helicopter which is carrying a electromagnetic system which is useful for the mineral exploration and groundwater exploration. This is the one of the unique method which only NGRA can do this kind of survey, and we will be able to identify the groundwater exploration as well as mineral mapping. So coming to the other areas like environmental monitoring and gas hydrates and the geotechnical investigations, these are some of the areas where we work on deeply with R&D research team. So our industry association has something like this. Almost all the integrated geophysical labs are involved in this, and the you can say the applications are varied from the public and private partnerships like Reliance and other companies. So today's topic, when it comes to the AI-based solar microsystem technologies related to solar energy. Before going to that, we will go with the basic fundamental to the what is solar energy and the introduction to the solar energy. So if you talk about solar energy is a form of energy implied from the power and heat of the sun and light. So basically, it's a solar cells. It's a basic unit of photovoltaic system. It is a device which is made up of semiconductor materials such as silicon, gallium to convert sunlight into the electricity. When the sunlight impacts on a solar photovoltaic cell, it generates electrons and holes at positive and negative junction respectively. If these junctions are connected to a DC electrical equipment, current is delivered into the entire circuit. This is the introduction to the solar energy. And why solar energy? So the importance of the energy is, see, there are many requirements, and the applications are coming up. A lot of energy is required, and when the populations are increasing, the energy requirement is at a high demand. We need to identify different kinds of alternative energy sources. In that, one of the best energy sources is solar energy. The reason was that it's a low maintenance and less hassle, and almost it's you can say naturally generated energy. So those are the particular reasons are there. Because of that, solar energy is more, you can say, a naturally available resource. So what are the key components of solar energy? Now you see, there are some of the solar energy. Uh, how the entire system, if you divide it into some of the key components, you can say the basic is a solar cell, and then when it comes to the like a batch production, like a solar array and solar panel and a battery and charge controller and inverter, and we'll see each component what it actually does, and it can makes the entire solar system. So this is the basic working principle of a solar photovoltaic cell. So it's a basic and principle, like you have you can silicon barrier, like p-type silicon, and PN junction method, like you have a photon and electron. When it transfer to the when it varies to the one potential to the another potential, the electricity is generated. So this is the basic principle. This is the equivalent circuit of the solar energy circuit. Now, when it comes to the characteristics, there is a current and voltage. How characteristics curve is varied, we can see in the slide. So coming to what are the advantages of solar energy is that when you see the advantages, the low maintenance cost, and reliability, and no pollution, no need of fuel, and sustainable. These are the main advantages of the solar energy. So again, when it have some advantage, always we have some limitations. When it comes to disadvantages, you need a large number of cells required. Always it's a intermittent and can't work at night. At the same time, when it there are like weather conditions, like cloudy, wind, and rainfall, when these are the, and also the major part is that you require a lot of land is required when you want to keep so much solar cells and generate huge energy generation. What are the applications of solar energy? There are various applications of solar energy coming, like household applications like water heating, solar cooking, heating and cooling of buildings, power generation, remote applications, transportation, pool heating. There are many societal applications as well as industry needs where many applications are run by using this solar energy. So we have seen the what are the components of the solar system. So in that, what is important is that solar photovoltaics. What is solar photovoltaic? We'll see, and why do we need it, and how is it made, and what are its components. So this is what we'll see in the coming slides. So why solar energy? See, you can see if you just see the some statistics, like the Earth receives almost 179 of petawatts of incoming solar radiation. Out of that, so much of solar radiation is available, and by using that, how the most of the world's population live in the areas with isolation levels like 150 to 300 watts, and mainly this solar energy is useful where the electricity is not available, and where there is no power is available. In such kind of places, the solar energy is more vitally utilized in the those kind of places. So when solar energy is being used for following purposes, like water heating, like already I discussed in earlier slide, advantages like solar cooking and water repayment. In the left side, you can see the some images like how they utilize the solar panels and for the societal applications. This is a basic photovoltaic cell, how it looks and how the method generates the solar energy. So in solar voltaics, this is the basic system with a block diagram which it shows. There is solar panels are available. So the energy generated from the solar panel is converted by the DC to AC by inverter, and from that it goes to the you can say a battery. So by using fuse box, it will be transmitted to the you can say consumer applications, and the remaining power is transmitted to the grid. This is the basic setup of the solar photovoltaic system. Sorry. So the photovoltaic systems are generally categorized into three distinct market segments, particularly for the residential rooftop and commercial rooftops and ground mount utility scale systems. So, what are the these are the large utility scale like solar parks and farms and rooftops, mobile and portable applications. Like these are also useful in the building integrated applications. See, for example, this is a huge area which is a power station which was generated. You have connected these photovoltaics in a grid manner, and you are able to generate the power solar energy by using these solar cells. So this is another mechanism example. You see a rooftop photo power station where they are using the photovoltaic solar panels on the roof of the building, and they are able to generate the solar energy. So with this kind of thing, they are able to generate up to 100 kilowatts and more of the solar energy. So this is another example where you can see a integrated photovoltaic system, and the building is made which the building itself having the inside the construction where you will be able to generate by using this photovoltaic energy. So this is the solar array where the number of cells are integrated in a array mode. So, and connected in series fashion, we are able to generate the this solar electricity. And how this is that the factors affecting this affecting efficiency of the solar energy is that because of isolation and weather and altitude and shading. Also, the angle where you keep the solar module is also one of the factor which affects the efficiency of the solar array. So there are also as to increase the efficiency of the solar panel energy efficiency. So the important thing is that the mounting of the solar panel also is very important. So if you see the modules are assembled into arrays and some kinds of mounting systems which may be classified as ground mount, roof mount and pole mount. So also not only the how you mount the solar panels, you need to have a orientation also towards the sun to increase the efficiency of the solar energy. So this is the one of the method they use as a tracker, particularly to tilt solar panel throughout the day, depending on the type of tracking system, and which is directly which is in the direction of the sun and the brightest area of the partly like a clouded or sky. So where we have the brightness more, the tracker will automatically move to the in that direction to increase the efficiency of the solar panel energy. So obviously, when I told to convert the alternating current to the DC, we use inverter. You can see in the picture there is an inverter box which converts the AC to the DC and transmit the energy to the you can say consumer transformer or the remaining power to the grid. So the battery is one of the source which stores the energy which generated by the solar panels. So the data energy is immediately stored into the battery. This is the immediate source of energy storage mechanism, which is in the part of the this entire solar energy system. The charge controller. This is the overall. You can say one of the programming control for the entire solar setup. Like the energy stored will be transferred through this charge controller. This will give all the you can say control signals to uh, the components of the solar system. So coming to the there is a like advanced methods like hybrid systems. Now you can see uh, by mixing the different kinds of energies like hybrid systems like combines with photovoltaic with other form of energies like parallelly there is a diesel generator and a biogas and like other energies will be combined together to generate the more energy, and the same grid will be connected with the like photovoltaic module as well as wind turbines, and these are the methods which you can combine together and we can generate this hybrid energy using these systems. Also, as you know, the Earth share compared to the water share is the Earth's share is very less. When you have a like a water bodies which is spreading across a few of the areas, and some of the countries is having most of the water bodies only. In that places, how you generate the solar energy is the floating solar arrays. So on water bodies, the solar arrays will be floating, and with this kind of floating technology, the energy is generated and it will be utilized for the we can say societal as well as industrial applications. Also, as already told, you can say consumer applications like home needs and other plants, like the solar cells are mounted on the rooftop arrangements, and it can be generated the solar for the street lights and telecommunication signaling, solar pumps and spacecraft and solar vehicles. So these are the some of the applications which can be used as a standalone mode. So if you see, just see the basic, information, particularly in India, solar power in India is the fast developing industry. Particularly, the country solar installed capacity reached almost 30.70 gigawatts till now, like up to I think roughly 2019. India has the lowest capital cost per megawatt globally to install solar power plants. The Indian government had an initial target of 20 gigawatt capacity for 2022, and already now we are crossed beyond the 20 gigawatt, and we are now at more than 30.709 gigawatt, which are achieved for I think 4 years ahead of the schedule. So when it comes to the International Solar Alliance proposed by Indian and founder member of that is headquarters in India with about 300 clear and sunny days in a year. So that is the reason we are unable to generate the solar energy ahead of the whatever target we have, and in, you can say almost 5,000 trillion kilowatt of hour per year we are able to generate. So in January 2016, the Prime Minister Narendra Modi and French President laid a foundation stone for the headquarters of the International Solar Alliance in Gorgon. The ISA will focus on the promoting and developing solar energy and solar products for countries like we can say the Tropic of Alliance. So around 120 countries are was announced in the climate summit, like COP Paris COP 2021. So now, till now, we have seen what is the basic solar system, and when it transformed into the microgrids, what happens? So the solar microgrids are localized energy systems that can operate independently or in conjunction with the traditional grid. So where you can see there are a lot of you can say components are available. So renewable energy and the generator, and how the grid is connected to the different applications, and from the grid how the energy is transferred to the different sectors. The technology they utilize actually renewable energy sources like predominantly solar power to meet local energy needs. Technology behind microgrids is evolving rapidly and driven by advancements in solar energy systems and energy storage. So now, what is the basic definition and importance? A solar microgrid typically includes solar panels, inverters, energy storage systems, and control software. They are crucial for energy resilience, especially in remote or disaster-prone areas. Their ability to provide reliable power can enhance energy access and reduce dependence on fossil fuels. So what are the technological components? Like already we have seen the earlier slides, like key components are like solar microgrid includes photovoltaic panels, battery storage, and smart controllers, and inverters like convert DC electricity from solar panels to AC electricity for use in homes and businesses. Like energy management systems optimize the generation, storage, and consumption of electricity. The main components you can see in the picture, which is depicting in the slide. So, what are the advances in photovoltaic technology? Now, you see, there are basically the energy is generated based on the kind of material. Now, there are advanced like new metals are evolving now. Those are the such as perovskites like being developed in improve the efficiency of the solar cells. But other than that, the bifacial solar panels can capture sunlight from both sides. So earlier, the energy is generated and captured on single facial solar panels. Now there are bifacial solar panels also are coming to increase the efficiency of the solar panels. And always the innovations in solar tracking systems allows panels to follow the sun, maximize energy capture throughout the day. Then when we are able to generate energy, but we also should know what are the energy storage innovations, particularly to save this energy and utilize in we can say as per the demand supply and demand ratio. Particularly the battery technology and especially lithium ion has seen significant advancements in energy density as well as cost reduction. Nowadays the lithium ion batteries are more advanced utilized in the every sector, particularly like the mobile phones and other you can say handheld devices. The lithium ion batteries are one of the most used energy storage mechanism. And also there are flow batteries and solid state batteries are emerging as promising alternatives for long duration storage. And improved energy storage solutions can enhance the reliability of solar microsystem during periods of low sunlight. There are also off-grid applications like solar microgrids are particularly beneficial in off-grid locations where traditional energy infrastructure is lacking. Say, for example, in you can say there are some areas where you don't have a power supply and electricity, where you don't have a option to establish this kind of electricity grids. In such places, these kind of applications are off-grid applications. These solar panels and energy is more useful to the you can say societal benefits. And also, as we know, the inverter plays a major role by converting the one form of energy into another form. Particularly, the smart inverters are enable better integration of solar power into microgrids. They enhance the grid stability by managing power quality and responding to fluctuations. Advanced features include like real-time data monitoring and remote management capabilities. These are the few features which are coming in smart inverters and other components. Also, it is because it's a source which is a natural source which is generated. You need to follow certain regulatory and policy developments. As already the governments are issued, there are many policy and regulations for utilizing and generation of this solar energy as well as for the both industrial as well as consumer applications. And this is the basic microgrid control system, which looks like how the grid system is that the energy is transferred to the different sectors, and this advanced control system optimizes the performance of solar. These, these systems can autonomously manage generation, storage, and load balancing. They provide users with valuable analytics tips for decision making. Also, these grids can be, you can say, effectively managed by using remote management. The remote management and monitoring will always help us without going physically and operating, and we can reduce maintenance cost as well as the manpower. We can reduce it, and this remote monitoring management can be very useful to the to reduce all the you can say increasing efficiency and reducing cost of the systems. So there are sustainable development goals. The solar microsystems align with several sustainable development goals. They promote affordable clean energy as well as supporting poverty reduction efforts. Microgrids contribute to climate actions by reducing greenhouse gas emissions. Then, what are the future trends in solar microgrids? The future of solar microgrids will likely include more advanced AI and machine learning applications, particularly like already we are seeing there are a lot of integration with electric vehicle charging infrastructure is expected to rise. Always decentralized energy trading platforms may emerge, allowing for peer-to-peer energy transactions. So when it comes to the what are the AI-based solar microgrids, the AI-based solar microgrids are energy that utilize solar power. They intelligently manage energy production and consumption through the AI algorithms. These microgrids enhance energy efficiency, reliability, and sustainability. So when it comes to the role of AI in energy management, the AI algorithms predict energy demands and adjust supply accordingly. They analyze historical data to optimize energy dispatch and storage usage. Machine learning techniques improve over time and leading to more efficient operations. So basically, the AI plays you can say advanced algorithms to predict energy and efficiently manage the supply and demands of the energy requirement by using this energy management system. So, what are the benefits of AI-based solar micro system? As I already said, it's a enhanced efficiency leads to reduced energy cost for the consumers, and AI systems can respond dynamically changes in energy supply as per the demand. And these microsystems micro contributes to sustainability by maximizing the use of renewable sources. So what are the we will see the what are the case studies and implementation. One successful example in the is deployment of AI in community solar projects. Another case involves urban areas where AI optimizes energy flow in real time. These case studies demonstrate significant reduction in carbon footprint and energy cost also. So what are the challenges in AI-based solar microsystem? So data privacy and security concern can hinder the adoption of these technology. Always when technology grows faster, there are some of the data privacy security problems which needs to be addressed. Also, the initial cost for this kind of AI-based solar microsystems may be a little bit barrier for the smaller communities. And technical integration with existing infrastructure poses additional challenges. See, some of the traditional equipment or traditional technologies what we have, it is very difficult to integrate with the advanced systems like AI-based systems. This is another challenge which you need to address by using this kind of advanced AI-based solar microsystems. So when it comes to the what is the role of artificial intelligence, AI will play a critical role in optimizing energy consumption and predicting demand patterns in microgrid systems. So the prediction is the more key point using this artificial intelligence, and machine learning algorithms can enhance the performance of energy management systems. AI can also facilitate predictive maintenance, reducing downtime and operational cost. These are the benefits of artificial intelligence in particularly solar microgrid systems. The cybersecurity is one of the important aspect we need to discuss. As microgrid becomes more connected, the importance of cybersecurity increases significantly. Protecting energy management system from cyber threats is vital for operational integrity. And developing such a robust cybersecurity measures will be essential for a future of the solar microgrids. So there are some microgrid management software which is actually in a simple way you can say these are the software management software which efficiently manage the operation of microgrids by forecasting energy demand and by supplying the such kind of demands. They facilitate remote monitoring as well as control of this entire, you can say, managing of the energy through the software. And integration with IoT devices enhances responsiveness and automation energy management. There, the IoT is one of the important technology where you have a, you can say a number of sensor nodes which is connected through the IoT network and algorithms, which can improve the efficient management of the entire solar microgrid. So this is one of the how the grid is connected to the integration of electric vehicles and how the energy is transferred and utilized for the electric vehicles and for charging purpose. Then there are we need to look at the financial models for solar microgrids. So innovative financing models and including power purchase agreements are gaining attraction. So the advantage of that, if we generate excessive energy, we can transfer the energy and we can create a financial model based on this kind of solar microgrids. These models make it easier for stakeholders to invest and implement microgrids projects. So I will show you some of the case studies which is running solar microgrids. Like you can see the projects in communities like Kodak Island showcase the feasibility of solar microgrids, which you can see universities and campuses are increasingly adopting microgrid systems for sustainability goals, and urban developments are integrating microgrid to enhance energy efficiency and reduce costs. In fact, even in our office also, NGR also, we have rooftop solar energy for running the you can say the daily electricity requirements. So, what is the social implication of solar microgrids? Access to clean energy can improve the quality of life in remote and rural areas. And solar microgrids can empower communities by providing energy independence. And educational programs surrounding microgrid technology promote awareness and engagement. So, international developments in solar microgrids. See, countries around the world are investing in solar microgrids as part of their energy transition, and international collaborations are fostering knowledge exchange and technology transfer. And global initiatives and funding are helping to scale up microgrid projects in developing nations. So, international you can say collaborations are important for this kind of technology. The reason was that the advanced equipments, instruments, where you can improve the efficiency of the and generation of the efficiency for the nation. Then, what is the role of stakeholders? Now, there are the stakeholders plays a major role like governments, NGOs, and private sectors. particularly for the business model. This solar energy generation, and collaboration among these groups can enhance the development and deployment of microgrids. The community investment is essential for ensuring their projects meet local needs. Because see, there are the community involvement is there because you need a lot of land for establishing this kind of solar microgrids, and you need local support for generating this kind of energy. So when it comes to the conclusion and future outlook, the AI-based solar microgrids represents a transformative approach to energy management, and their potential to enhance renewable energy use is significant for sustainable development. And continued advancements in AI will drive further innovation in microgrid technology. Thank you. So, and one more thing I want to share as part of the geophysical surveys which we conduct from our institute. So, we have found advantage of the solar energy and solar panels. See, we do a lot of geophysical surveys in remote places like forest and many geological places. In those places, getting power and running our instruments is very difficult. In those areas, the solar panels we have and which is attached to the instrument which needs to acquire the data, and by using those solar panels and instrument we are able to acquire the data and process it and see the what are the earth applications we are able to carry out. These are the major application, particularly for the solar energy utilization in particular geophysical surveys. Thank you.
Thank you, sir.
Any questions? Yeah, the CSR will be sharing the data sets based on the, you can say, if it is a research point of view, the CSR can be shared the data, no issue in that. The lifetime of the solar panel.
Sir,
will be-
one more. Sir, what
Yeah,
are the
tell-
MPPG techniques are available, sir?
Pardon me, can you come again?
What are the MPPG techniques are available, sir, in microgrid solar, sir?
What are the?
MPPG techniques you use, sir, this microgrid technology?
No, we use only off-the-shelf available solar micro panels only. Our requirement was very minimal, but when it comes to the microgrid, it is a huge plant kind of automation.
Okay, what is the megawatts you are using, sir? Total source capacity?
No, we are not established any solar microgrid.
Okay.
We were used only for geophysical surveys only.
Okay, sir. We want to do some real time, that's why, sir. We want to do some research on microgrid, that's why we are asking, sir.
No, microgrid. Yeah, we are the application user for the solar panel energy and microgrids.
Okay, sir. Thank you, sir. Thank you for your information, sir.
Thank you.
Sir, good evening, sir.
Yeah, tell me.
Sir, I have a small doubt, sir. How
Yes,
how
sir, yes, sir.
AI play how AI play on the solar panels, sir, solar system, sir?
So actually, AI is you can say a prediction mechanism for every application. See, when it comes to the when you implement a AI algorithm on any application, what it does, it takes the you can say a past historical data and it
Yes, sir.
analyzes
Yes, sir.
and it process it,
Be-
and based on the
Before that, we need
yeah
before that we need to predict. Na? So this
yeah, that is what so the AI always have the historical data. Based on that only it can give you
yes,
the
sir.
possible prediction what you can say possible prediction limitations, and based on that only we will be able to take up the few actions.
Okay, 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 okay. The particular action only you can able to access through the AI.
Yes, that also you need to
Okay.
feed the your historical data, like your grid is generating every day what is the kind of energy, and it takes all the parameters like what is sunlight is generated, and few many parameters it is you can take as
But
input
the
process.
energy is transient only, na?
Yes, yes, transient
So
only, yeah.
energy, yeah, okay. How you can able if it transient, na, we can't use for that specified applications, na, it gets some issues.
No, what we are doing, we are generating and we are storing.
Okay,
So the
okay,
stored energies we are utilizing actually. So the entire control
okay,
of the
fine, sir.
automation will be in the process of the loop.
Okay, fine, sir, fine. Thank you for got it, sir. Got it. Thank you.
Any other questions? Yes, pollution due to e-waste of solar. See, mostly you can say the solar panels are reusable mostly. So we can say the percentage will be not like a normal e-waste.
Dear participants, any questions? If any questions are there, you can ask. Otherwise, we'll come end of the session.
Hello? Hello?
Yeah,
Yes,
tell me.
ma'am. You can ask.
Good evening, sir.
Good evening. Good evening.
So actually, what's my doubt is actually we are using the solar system now, na? At present, whatever now now this gen at present time. So what is the main difference of this solar system and what is now you are telling about that one?
No, there is nothing different. So only the capacity wise and the you can say the what kind of capacity it can generate, and what is the
Okay.
kind of array you are able to you are having. This is what the difference, nothing else. So
Acha,
based
acha.
on if
So
you have the number of photovoltaic arrays are more,
mhm.
and there is a sunlight on the particular day, then the energy will be generated more.
Yes.
There is nothing difference. Only thing the capacity is it will increase
Means
when it goes to
if
microgrid.
only
When it,
normal temperature means whenever sunlight is also not there,
yeah,
only by
even
the
even some brightness also it will capture.
Acha. So it increases the means capacity of the generation.
Yes.
Okay. Okay, thank you.
Thank you.
Dear participants, if any further questions are there, you can ask. Thank you, sir. Thank you for your valuable information. The session was highly informative, and we have gained a valuable knowledge on AI-based technological advancement of solar microgrid. Actually, this will help us in research work at the same time in teaching field also.
Thank you. Thank you very much.
Thank you. Thank you so much, sir. Thank you, dear participants. We'll see you in the next session.
Thank you.
Thank you, sir. Thank you so much.
Thank you. Bye.
Ma'am, when is the next session, ma'am? When it starts?
The next session will be starting 7:30, sir.
7:30.
Mm.
Okay.
We'll share you.
7:30.
We will stay on the line, or
Actually, the next session link will be posted in the group. You can join through that link, sir.
oh, that is another link, yes?
Yes.
Oh, okay, sir. Okay, thank you. Thank you.
That will be posted in the WhatsApp group. You can join through the link.
Okay, okay. Thank you, ma'am.
And also
We-
already we sent a mail. Can you check? Mail
Okay.
also we have sent.
Okay, thank you, sir.
Okay, thank you very much.
Thank you to all the participants. Thank you, sir.
So please join in the other link, please. Thank you, madam.
From 7:30 onwards to